Okay, so now, very similar objective to the last one, similar target. The only difference is instead of one-step equations, we're looking at two-step equations. So we're still going to use inverse operations with the whole point of isolating the variable, but now in two-step equations. And here are the two steps we're doing. So if you were absent, make sure you please write those notes down. And this sequence is very important. So number one, we remove any addition or subtraction by using inverse. Any addition or subtraction that's happening next to the variable. Number two, we remove any multiplication or division by doing the inverse of whatever's happening to the variable next to the variable. And you'll see what I mean in a second. But please, it's very important to make sure we do it in that sequence, meaning we first remove any adding or subtracting that's happening. Secondly, we do the multiplication or division, okay? The reason for that we could talk about in a little bit. Here's an example. So remember, the whole goal in these algebraic equations is to get this variable by itself, which means it's going to look like this, x equals. We want to solve for x, and really what we're doing is just getting that variable by itself. So right now, there's a couple things next to it. There's a 3 that's multiplying it, and there's a minus 11 that's next to it. So we want to get those things out of the way so that the only thing left will be this x, which means we have a solution to the equation. First, like we said in step 1, we remove any adding or subtracting that's happening next to the variable. So we can see that it's subtracting 11. We remove it by the inverse of subtracting 11, which will be adding 11. So make sure you do the inverse right underneath the thing that is being subtracted in this case. So we're going to add 11 to that side. Always in algebra, you got to do the same thing to the other side of the equal sign. And just like in our one-step equations, this is going to cancel out. You could think about this as a negative 11 and a positive 11. It cancels out to make 0. So we're getting one step closer to getting our x by itself. Right now we still have a 3x over here. I'm basically just bringing this guy down here. And I still have our equal sign, and then we do the math of 22 plus 11. Okay, so now we're looking at a one-step equation, because we already did the one step. 3 times x equals 33. Again, we want to use the inverse of what's happening next to the variable. It's multiplying by 3, so we divide by 3, writing it like a fraction, because that can be division as well. Again, just like the one-step equations, 3 over 3 is just 1. 1 times x is just x, so we could really just simplify this by crossing it right out. You're left with x on this side, and the math of 33 divided by 11. I'm sorry, 33 divided by 3, which is 11. Okay. One thing you might want to do is just double check your solution. So you go back to your original equation, 3x minus 11 equals 22. Instead of the x, put the 11 in. We think it's 11, let's put it in and test it. When we put it in where it's multiplication, like 3x means 3 times x, make sure you use parentheses to indicate multiplication, okay? 3 times 11 minus the 11 that was already there in the equation, and if that equals 22, that means we have a correct solution. So we do the math on this side. This is kind of what we already did when we checked it, but it's just kind of double checking it, and we can see that we have a balanced equation, okay? So the answer to this is x equals 11. Okay, let's try another one. 3 plus x over 4 equals 11. We kind of focus in on the x, remove what's around it. Now, this is a little tricky because it looks backwards, but 3 plus x over 4, we want to get rid of any addition and subtraction. So this is like 3 being added to the x plus 4. We remove that through subtraction. Okay, so we're just going to go right under here. This one's a little trickier, I'll admit that. Then we have to go to the right-hand side. Do the same thing, right-hand side of the equal sign. Okay, this is going to cancel out because a 3. You see, here's the thing with this one that makes it look tricky. This is actually a positive 3. Okay, there's just no plus sign there because sometimes with positive integers, you don't need the plus sign, or sometimes it's not there. So if you think about 3 minus 3, or like you're combining a positive 3 and a negative 3, either way you're going to get 0. Either way it's going to cancel out. You're left with x over 4 equals, and we do this math, and we get 8. Now here's another tricky thing you'll notice. I did not bring this plus sign down here. I don't really need to. And the reason that's tricky is because this is actually indicating it's a positive x over 4. But for now, we can just not bring it down, not worry about it, and move on to our next step. Okay, now we have an x, our variable that we still need to get alone. It's being divided by 4. The opposite of being divided by 4 is multiplying by 4. Multiplication is going to look like this. I like to put in parentheses just to indicate the multiplication. Now again, on the left-hand side here, this is going to cancel out. I would want to extend my fraction bar just to give me a better visual of the canceling out that can happen here. This extends a little bit. Then 4 over 4 is just 1. 1 times x is just x, so I can just eliminate all that. I'm left with x equals 4 times 8, or 8 times 4. Same thing, it's just 32. Okay, double check this thing by rewriting the whole equation. 3 plus, if I think my x is 32, let me put it in there in place of the x, over 4 equals 11. Okay, now you do the math. 32 over 4 is 8. We still have our plus 3, and yes, that does equal 11, so we have a correct solution. Okay, another tricky one, and then I think I'll get you to indie work here. X plus 2 over 3 equals 9. Now I told you before, the very first step is to remove any addition or subtraction that's next to the variable by inverse operations. Now the only thing that's tricky here is that it looks like you want to remove this plus 2, okay, because that's addition. We would remove that with a minus 2 or a negative 2. The only problem is that x plus 2 is a numerator. This whole thing, both terms here, is part of the numerator. So we can't just subtract part of a numerator and get away with it. So really the whole thing that's happening here, this is just one big fraction. Fraction means division. Okay, so what we really need to do is multiply by the inverse of what it's dividing by. Okay, I know it's a little tricky, that's why we got to keep practicing with this. So this is dividing by 3. The x, we're going to try to get him by himself. So instead of dividing by 3, we're going to multiply. We're doing the inverse. Multiplication is going to look like this. Both sides of the equal sign. Again, I like to extend this fraction bar, otherwise it looks like this is kind of hanging out. Okay, now, again, like before, 3 over 3 is just 1. If we try 1 times x plus 2, it's just going to be x plus 2. So we're left with x plus 2 on this left-hand side. Oopsie daisy, my iPad is about to die, it looks like. Let me try to plug it in. Hold on. 1 second here. It is plugged. Okay. So, x plus 2 equals 9 times 3, which is 27. Okay? I now have to get rid of that plus 2 with a minus 2 on both sides. This cancels out. You're left with x equals 25. And if you were to plug it right back into that equation, you would see that that's true. For your independent work, this is the page. These are the problems I would like you to do. Make sure you show questions and answers, and please do not try it with mental math. I need you to do all the steps in the same way that we've been doing together.